Jamb 2026 candidates still under refractive index, question 2. Okay, refractive index, question 2. Refractive what? Index. Okay, question 2. All right. Jamb must repeat question 2. The question reads, calculate the refractive index of the material for glass prism in the diagram above if the refractive angle is 60 degrees and the angle of deviation of the ray is 30 degrees. Okay, so for this question, you get a diagram wey dey attached to this question. But I no get time to draw that diagram. Okay, even without the diagram, we can use our imagination to solve it. Even people say if you go give them the diagram, make they solve, they don't go even use the diagram solve. So let me just teach you what I can teach you, okay? Because time not dey. All right. So looking at the options we have here, all options are represented in decimal, no units. So first of all, what we go do? Since na question under refractive index, make we quickly write out our refractive index standard formula. The same will find wetin calculate the refractive index of the material. So the same will find refractive index question mark. All right. So now this thing we define. So the formula of refractive index is what? Refractive index is equal to sine, the same formula we will use just now. Bracket open A plus D over 2 over what? Sine. Okay. Bracket open A over 2. Bracket close. So this one I be the formula. So what we go do? Maybe look wetin they give us to take solve. Okay. Everything where they give us, all the parameters where they give us to solve. They say refractive index of the material for glass prism in the diagram above if the refracting angle. So this one are the angle. This A. So they give us angle A is equal to 60 degrees. Okay, and the angle of deviation of the ray is 30 degrees. That's this D now angle of deviation equal to 30 degrees. Okay, which other thing they give us? They can say we'll find this question too easy, very cheap and fast. If you know what you do to solve this question, I'm not lie you. What you need to do now to solve this up, solve this down, they can't use the other formula of refractive index. That's incident angle over refracted angle. Then you get your answer. Okay, you use incident angle over refracted angle to get your final answer. All right, so maybe we'll go straight into the business. Sharp. So substituting this into this formula, we are now going to have we are now going to be left with more fair do the numerator before we do the denominator. So the numerator will give us waiting. We get sign for here, we put our sign. Okay, bracket open. Waiting be A na 60 plus D. Waiting be D na 30. Okay, over 2. Okay, bracket close. Maybe we solve this one, get the answer. More don't say we don't get numerator. Okay, so this one will give us if 60 plus 30, that's 90. Okay, so 90 divided by 2 will give us waiting 45. Okay, that's angle 45. So we'll solve the denominator. So for denominator, we get sign there too. Sign. Okay, bracket open. Waiting be A now waiting 60 over waiting 2. Bracket close. So this one, if you solve 60 divided by 2 will give us 30. That's angle waiting, angle 30. Okay, remember, say for refractive index, now sine we take the solve. So sine deal with them. So what we get now for here now, sine equal to sine 45 degree and equal to waiting equal to sine 30 degrees. All right. So now both of what we get. So this one are the numerator, this one are the denominator. So what we go do now? Now to apply the law of refractive index, sharp. Okay, apply the law of refractive index sharp to get the answer. Okay, so that law of refractive index which states incident angle over what? Refracted angle. That's refractive index is equal to what? Sine of the incident angle, that's sine I over what? Sine R. Okay, that's refracted angle. All right. So if you put as since no need, but it's supposed to get angle degree. Okay, like this. So now this one, now the formula. So if we substitute what we get for here, this one where they up now incident angle. This one where they down now waiting now refracted angle. All right. So the up one now incident angle, we can get sine waiting 45 degree over waiting sine 30 degree. All right. So you go fix up waiting the sine 45. Now I ask you, you don't know. You can't use your Jamb calculator to solve it. Waiting the sine 30, you can't use your Jamb calculator to solve it. So what we go do now, I say we go use SOHCAHTOA. All right, SOHCAHTOA. Okay, where they teach you that year for maths. Okay, for your secondary school, where they teach you SOHCAHTOA. So is this SOHCAHTOA we used to find sine 45 and sine 30. So in the SOHCAHTOA, sine 30 degrees is equal to 0.5. In the SOHCAHTOA still, sine 45 degrees is equal to what? Root 2 over 2. Abi? Yes, root 2 over 2. And this root 2 over 2 is equivalent to 0.707. Okay? Yes. That's it. And another one, again, might just give you the final one. Sine 60 degrees is equal to, what will be sine 60 again? Root 3 over 2. And this is equivalent to 0.86 something. Maybe 866 or so. Alright? So, now this one, the common SOHCAHTOA, they get the one for cos. So, learn them. Now, angle, they take the final. You go just draw angle like this. Here where punk the face punk will be opposite. Okay, here will be this place will be adjacent. Then here will be hypotenuse. Okay, hypotenuse. So here, opposite hypotenuse. So now here you go to find out. So root 2, 2 and root 3. So it's easy. So get used to your SOHCAHTOA. They don't teach all these things for primary school. So since we don't know all this, now to waiting, bring all of them come here. Since we apply this formula, sine 45 over sine 30. Waiting be sine 45 for here, for this SOHCAHTOA, sine 45. Root 2 over 2. Root 2 over 2. That's, we are now going to be left with refractive index is equal to root 2 over 2 over, waiting be sine 30. Sine 30 now 0.5. 0.5. So we go first do this small one first before we can finally divide with this one. Alright? So remember, say 0.5 means half. Okay, so and half is equal to 1 over 2. Okay, so if we put this big over here, we can put 2 over root 2. This denominator, if we cancel this denominator, this can cancel this. Okay, and we are now going to be left with refractive index is equal to root 2 over 1. So root 2 over 1 now waiting. Root 2 divided by 1 will give you the same root 2 equal to root 2. So what is the square root of 2? Put that for calculator, it will give you 1.414 or so. Okay, so this is our final answer, either root 2 or 1.414. Among the options, pick the correct option and drop it in the comment section for me to believe you understood this. Very, very simple. I promise you that I will make it very simple. All you need to do, follow the procedure and you get the answer. I will see you in the next class. Jamb 2026 candidates, you are welcome to today's physics calculation class. Please, if you need any help, you are a last minute preparation candidate, you have not been preparing, you are panicking that you are going to fail this Jamb, come, I will help you. I help last minute preparation candidate, okay? Come and let me help you. Get help before it's too late. I don't want you to fail. I've been doing this for almost 4 years now. So get help. This is my WhatsApp number. Contact me for help. All right. I have a plan that I can use to help you. I also have short and simplified lesson notes straight to the point that you can quickly read that will make a difference in the outcome of the Jamb UTME 2026. The question we have here is under magnification, and it's a high yield in Jamb UTME 2026 physics calculation. It's a must that you are going to see a question from magnification. So Jamb must repeat question 1. The question reads: calculate the height of the image formed by a pinhole camera or more of length 12 centimeters used to photograph an object 60 centimeters away from the hole and 70 centimeters high. All right, so this is the height. So they said we should calculate what? The height of the image. That's what? Image height. All right. So looking at the options, all options are represented in what? Meter. So what do? They said we should find what? Image height. That's, we can write image height as V. Okay. Calculate the height of image. We can write image height as V. Okay. You can write it as V. Or you can write it as HI. Okay. Equal to question mark. This I stands for H subscript I. I stands for image. H stands for height. V stands for image height as a whole. So you can write it any style you choose, but just know saying now what the two represent. Alright. So since they say we'll find this thing, maybe we first of all write out the formula for image height. Okay. Image height gets formula. No. So we go use magnification formula. Since image height they say magnification formula, we go write magnification formula, then come make image height the subject of the formula. Since now we define, we can derive the formula by ourselves. Now we Jamb one make you do. Okay. Magnification M is equal to distance of image over distance of objects. Or you can put it as V, image distance, over what? Object distance U, depending. Two of them mean the same thing. Alright? This same magnification has another formula, which is equal to, is the same thing as, or let me just put it here. Magnification can also be equal to image height, image height, okay, which is what? HI, over what? Object height. This is the second formula for what? Magnification. Object height. Alright? So magnification can either be equal to image distance over object distance or image height over what? Object height. As easy as that, easy peasy. Alright? So for pinhole cameras, since we are dealing with pinhole cameras here, pinhole camera, they say length of maybe pinhole camera. For pinhole cameras, image distance is equal to the length of the camera. That bus, a pinhole camera, you know, it's like a bus. Okay? A bus. Okay, now so pinhole camera they be, who go come here. Ray of light will pass, enter. Okay, will come from the image inside. All right. So that bus, the image distance is equal to the length of the camera. It's the length of the camera that determines the what? The distance of the image. So for pinhole camera, okay, for pinhole cameras, okay, image distance is equal to the length of the camera. I've taught this before in the notes, in my lesson notes. I've taught this before, the length of the camera. So since image distance is equal to the length of the camera, that is going to help us to solve. Alright? But first of all, let's write out all we were given. Okay? Among the in the question, they gave us what? They gave us calculate the height of the image formed by a pinhole camera of length 12 of length. Remember, the length of the camera is the image distance. So the image distance, which is what? Image distance, di, is equal to what? 12 centimeters. What else did they give to us? Used to photograph an object of 60 centimeters away. This one now is object distance. Okay, that's object distance equal to what? 60 centimeters. Okay, so did they give us any other thing again? Away from the hole and 70 centimeters high. So this one is what? This one they give us here 70 centimeters. Wait, 70 centimeters high. Okay, this is the what? Away from the hole and 70 centimeters high. So this one is the height of the object height. Wait, centimeters high. Wait. Used to photograph an object 60 centimeters away from the hole and 70 centimeters high. So this one is the object height. All right. So this one is the object height. That's HO, height of object 70 centimeters. All right. So they told us to find what? The height of the image. All right. So what do we do? What do we do? See what they give us. They will give us about abidi. This one they inside this formula. This one they inside this formula. You see? So if you are a good mathematician, all you have to do is to what? To join these two formulas together, solve and get your answer. But because say for people we're not too good for maths, okay, make we do and small for them. Okay, those will be say good for maths well, all you need to do just mesh the two formulas together, substitute and get the final what you are looking for. All right. But first of all, we go first do the one where we say I own many pass so that we will get magnification. All right. More first do one, take more first find the magnification first. Okay. So we go use the one where we say they complete. Like this one now, image distance and object distance. Here we get two of them. So we'll use this one to get magnification first. Then we'll go use magnification. They solve for waiting image height. All right. So we'll use this formula now. M is equal to what? Di. What's distance of the image? 12 centimeter. 12 over what? 12 over what? What's do? Do. That's 60. Okay. So 12 divided by 60 will give us what? That will give us 0.2 or so. All right. Since that one don't give us 0.2, this one magnification now is equal to 0.2. Since we don't get magnification, we're going to apply the formula of magnification. Okay, see the formula of magnification, we're going to apply this second formula. Okay, M is equal to HI, which is the image height, over weighting object height. Okay, H. If we substitute what we get here, we get image height here. Final. We don't get that, now we define. Okay, we get object height here. Final. See object height. We get magnification, yes, see magnification here. So we'll come put our magnification here, say we don't find out, equal to 0.2. We don't see magnification. So, since we get magnification and we get object height, and we look for this one, we'll come make this one subject of formula. Very easy. So if this one come down, it will come be M times HO. Easy. So HI, which is waiting image height, is equal to magnification times HO, which is waiting object height. Alright? So we substitute. Okay, HI is equal to waiting magnification at 0.2. See here. Times waiting be HO. HO now 70 centimeter. So that one will give us waiting. 2 times that will give us 14 centimeters. All right, that's the answer. So among the options, pick the correct option and drop it in the what? The comment. Just repeat question 2. The question reads: an object is placed 20 centimeters from a concave waiting mirror of focal length 15 centimeters. Calculate the linear magnification of the image produced. They say we'll calculate waiting magnification. And what is the formula of magnification? You know, say you get two formula, but we'll write out the formula according to waiting they give us here. An object is placed 20 centimeters from a concave mirror. So this one don't tell us say this one an object distance. So that one don't tell you say now the distance code. Now you will use. All right. So magnification, we'll write formula of magnification. The one we get distance M is equal to V, which is what? Image distance over waiting object distance. All right. So since this one is the formula of magnification, we'll go write out all the things where they give us more. They solve giving. Waiting they give us, we'll know how our approach following the 11 steps of answering physics and chemistry calculation questions. All right. So this one already, this one are waiting, this one our object distance already. So we'll come put and say our V is equal to waiting 20 centimeter. Okay. Now that one be our V. Is that the correct thing? No, that's wrong. That should be the image distance. Wait. An object, we have to be careful, maybe for no fee. An object is placed 20 centimeter from a concave mirror of focal length 15 centimeter. So this one, so an object is placed 20 centimeter from a concave mirror. Now object distance now, so now U no be V, so U is equal to 20 centimeter. All right. Then they're gonna give us focal length. Yeah, focal length 15 centimeter. Focal length is equal to 15 centimeters. All right. Waiting else they give us, they're gonna say make we find waiting, calculate the linear magnification of the image produced. They're gonna say we'll find magnification, which is M is equal to question mark. All right. So this one are the formula of magnification. This one are magnification formula. Okay. This one are magnification formula. If you look here, we don't get V here. They don't give us V, which is waiting image distance. They don't give us. only u, now they give us CU here 20 centimeter. All right, and we want to look for magnification. We know if we find out like this now, so that means say they want make we go find waiting. They want make we go find this V where they don't give us here. So okay, so how we go to find this V? How? Since we get focal length for here and our V we dey look for, we get U for here. Make we apply the length formula. All right, the length formula is equal to 1 over F. Okay, is equal to 1 over U plus 1 over V. All right, so this one is length formula. Since if we say now V we define, we'll come make V the subject of the formula. Then we'll come use these two. They waiting, they solve. All right, but before we start to solve, we have to note one thing. Okay, before we start to solve, but more make V the subject of the formula, or make we first note. More note first. Distance, which is U, is what? Is positive. That's now plus positive for real objects. Okay, for real objects. Okay, so in real objects, and you know the kind of length where they form real objects. Okay, okay, so it's positive. You use plus. Focal length. Okay, focal length is also what? Positive. That's now plus you will use. Okay, for waiting for concave mirror. Concave mirror. I don't teach all these things before for my lesson notes. Okay, so this one now go be positive, and you see here plus 20 and minus 20. So plus 20 and 20 are the same thing. Okay, this one now supposed to be waiting positive 2 plus 15 and 15 are the same thing. So we know we change that. So we fit just use this formula and waiting solve. So make we make 1 over V the subject of the formula. Make we solve. All right. So if 1 over V come this side, we will carry minus 1 over V is equal to, if 1 over F come this side, it will come carry minus. Okay, 1 over U minus 1 over F. Okay, so we'll come substitute inside this one, take solve. Okay, we'll do one for under here. Okay, then if we substitute, we'll come get 1 over V. Remember, I carry minus 1 over V is equal to, waiting be U 20, 1 over 20. Waiting be, okay, put our minus, waiting be F 1 over 15 or 15. Okay, we put our 1 over 15. Waiting, I tell you, say anytime we get 1 over something, then you do. You go times the weighting, the two denominators to form numerator. Then you can't use the sign with the here. You apply it to the weighting, the denominators to get weighting, the denominator. Okay, so if now plus day here, you go plus the two denominators. If now minus day here, you go minus the two denominators. So make we first times to form the numerator. So equal to do numerator, oh now we go do 20 times 15 over. Then since now minus day here, we can do the denominator, which is to minus 20 minus 15. Okay, hope say you get that. Equal to weighting, 20 times 15 will give us 300. Okay, over weighting, 20 minus 15 will give us 5. And 300 divided by 5 will give us 60 or so. 60. So our 1 over V is equal to what? 60. 1 over V equal to 60. So our V now is equal to 60. 60 centimeter. You get that now. Hope say you get that now. So now, what we will come do next? Remember, say what carry us enter this one chance. Now because say we don't get V, so we try to find V. May we apply this formula to solve for magnification. So now is the time to apply this formula to get our magnification, pick our correct answer, and get out of this place. M now is equal to V over U. Okay. So our M, since we don't get V, we will come put V here. 60 over waiting be U. U now 20. Okay, over 20. That will give us what? 60 divided by 20 will give us waiting. It will give us 3. Okay, so our magnification is equal to 3. So among the options provided, pick the correct option and drop it in the comment section. Make I give you shortcuts where they work for only mirrors. No use them for lens, so only mirrors. Okay, if they ask you to find magnification for mirror, okay, the fastest way, shortcuts for only mirror. No use them for lens. So my indicator here, shortcut for mirrors. Okay, no try and for lens. So apply this formula. M is equal to F over F na focal length U minus F. Okay, it will all give you the answer. So if you look waiting, they give us more they solve. They give us U. They give us F when we solve. Yes, they give us F. Okay, U and F. So that waiting we do. If we substitute that, we can get waiting be F na 15 over waiting be U where they give us U na 20. 20 minus waiting be F na still 15. Okay, if we simplify this, waiting the bottom here we do and we can get M is equal to 15 over 20 minus 15, 5. Okay, therefore 15 divided by 5 will give us 3. That's the answer. You can see how fast it is. But you apply it for only mirror. If you apply it for less, it not will work. See you in the next class, Jamb 2026 candidates.